Stop for a second. There are objects in space that shouldn't exist. Stars heavier than theory allows. Black holes that formed too early in the universe. Planets bigger than physics predicted. Astronomers keep discovering things that force them to rewrite models, which means something uncomfortable. We might not understand the universe as well as we think. Science isn't a finished book, it's a constantly rewritten guess. If you want to explore the mysteries that still break physics, subscribe. For decades, our understanding of stars has been built on fundamental principles. We know how they're born, how they burn, and how they die. One of the cornerstones of this understanding is the Chandrasekhar limit, which dictates the maximum mass a stable white dwarf star can have, about 1.84 times the mass of our Sun. Beyond this, a star is destined for a more dramatic end, often a supernova. But then, astronomers started observing phenomena that just didn't fit. Take superluminous supernovae, or SLSNE. These explosions are hundreds of times brighter than typical supernovae, suggesting they originate from stars far more massive than our models predicted could exist, or at least could explode in such a way. Some theories suggest these could be pair instability supernovae, where stars between 130 and 250 solar masses become so hot that gamma rays spontaneously convert into electron-positron pairs, causing a catastrophic collapse and explosion that leaves no remnant. The problem? Stars in this mass range were thought to be extremely rare, or even impossible to form under standard conditions. Yet, we're seeing their explosive deaths. These observations challenge our very understanding of how massive stars form, evolve, and ultimately meet their end, pushing the boundaries of what we thought was possible in stellar physics. Black holes are born from the collapse of massive stars, or they grow by accreting matter. This process takes time, a lot of time. For a supermassive black hole, like the one at the center of our galaxy, to reach millions or even billions of solar masses, it needs billions of years to feed and grow. So imagine the shock when astronomers discovered supermassive black holes weighing billions of times the Sun's mass, existing less than 1 billion years after the Big Bang. The universe was barely in its infancy, a cosmic toddler, and yet these monstrous black holes were already fully grown. One such behemoth, JO 313 1806, was found to be 1.6 billion times the mass of our Sun, existing just 670 million years after the Big Bang. How could something so massive form so quickly? Our standard models of black hole growth simply don't allow for it. This discovery forces us to consider alternative, more exotic formation mechanisms. Perhaps these early black holes didn't start from stellar remnants, but from the direct collapse of massive clouds of primordial gas, bypassing the stellar phase entirely. Or maybe they grew at rates far exceeding what we currently understand. Whatever the answer, these ancient cosmic giants are rewriting the timeline of black hole evolution and challenging our understanding of the early universe itself. When we first started discovering exoplanets, we expected to find systems much like our own. Rocky planets close to their stars, gas giants further out. Our models of planet formation, based on our solar system, predicted a certain order and size distribution. But the universe had other plans. We found hot Jupiters, gas giants more massive than Jupiter, orbiting incredibly close to their stars, sometimes completing an orbit in just a few days. Our models struggled to explain how such massive planets could form so close to their suns without being ripped apart or migrating inwards. Then came the super-Earths and mini-Neptunes, planets with masses between Earth and Neptune, a class of planet almost entirely absent from our own solar system. These worlds are incredibly common, yet their formation mechanisms and atmospheric compositions are still a mystery. Are they rocky cores with thick atmospheres or icy worlds? How do they form in such abundance? These discoveries have forced planetary scientists to completely overhaul their theories of planet formation and migration. It seems planets are far more dynamic and capable of forming in a wider range of conditions than we ever imagined. The universe is a much stranger and more diverse place than our initial models allowed for. These aren't just isolated anomalies. Each of these impossible objects represents a crack in our current understanding of the universe. They challenge fundamental theories that we once considered robust. When we find stars that are too heavy, it questions our models of stellar nucleosynthesis and the very forces that govern a star's life and death. When black holes appear too early, it forces us to reconsider the conditions of the early universe and the nature of gravity itself. And when planets defy our formation theories, it means we're missing crucial pieces of the puzzle about how solar systems come to be. And let's not forget the even bigger mysteries: dark matter and dark energy, which together make up about 95% of the universe, yet remain entirely invisible and unexplained. These known unknowns are a constant reminder that our cosmic map is far from complete. Every new discovery, every anomaly isn't a failure of science, but an opportunity. It's a signal that there's more to learn, more to explore, and more to understand. It means our current models, while incredibly powerful, are just approximations, waiting to be refined or even completely replaced by a more comprehensive truth. This is the true nature of science. It's not a static collection of facts, but a dynamic, evolving process. It's a continuous cycle of observation, hypothesis, experimentation, and revision. Every time we find something that breaks physics, it's not a sign of weakness, but of strength. It shows that the scientific method is working, constantly pushing the boundaries of our knowledge. It's a testament to human curiosity and our relentless drive to understand the cosmos around us. The universe is not obligated to conform to our expectations, and that's what makes it so endlessly fascinating. The fact that there are objects out there that shouldn't exist, that defy our current understanding, is not a cause for despair, but for excitement. It means the greatest discoveries are still ahead. The universe is a vast, enigmatic place, full of wonders that continue to challenge our perceptions and expand our minds. It's a place where the impossible often turns out to be just the next frontier of understanding.